Hi, welcome back to Mrs. Thompson's classroom. Today we're going to be looking at transforming functions. Basically what that means is we're going to take the graph of one of our basic functions like x squared or the absolute value of x, and we're going to move it all around. We're going to left, right, we're going to shrink it and stretch it and all sorts of stuff. So in the first part of this video, we did the moving, the left and right and up and down. Today what we're going to do is the stretches and shrinks. And then we're going to do some examples of putting all of that together. So let's get started by looking at y equals x squared. Okay, so you can see this blue curve here, and this point right here goes through 0, 0. If I multiply this function by 4, basically I'm taking an x, I'm squaring it, that gives me a y value, and now I'm going to multiply that by 4. So I'm actually affecting the y values of each point. And so when I do that, I get this black curve. You can see that this point got moved, got stretched upwards. Okay? Now when I take and I multiply it by a 4th, now I'm taking each y value and I'm going to make it smaller by a factor of 4. And so I get a curve that looks like this red one. So you can see this point here moved down. Okay, so they're staying the same shape, but they've been stretched or shrunk vertically. Okay, so how do we determine if it's a stretch or a shrink and by how much? So that's the question. So what is the general rule? Well, if I take a function and I multiply it by a constant, okay? So if my function is a quadratic, I'm going to actually do the squaring, I'm going to calculate the function, and then I'm going to multiply by some number. If c is greater than 1, this is going to be a vertical stretch by a factor of c. Okay, but if c is between 0 and 1, so it's a fraction like a half or a fourth or a third, then it's going to be a vertical shrink by c. Okay, so we'll keep that rule in mind as we move forward. And we're going to look at something slightly different. You see in this one, we have this 0.5, but it's inside those parentheses. So we're multiplying x by a half, and then we're cubing it. So let's see what effect this has. I know it goes through this point 1, 1. But how does the new function get to 1? Where do I get that same y value? Well, I would have to use x equals 2, right? Because now I'm going to have 1/2 times 2, and then I'm going to cube it to get 1. So instead of having the point 1, 1, I will have the point 2, 1. And the function actually looks like this black curve. So you can see that this point here gets moved outward. Okay, now in the second example here, I'm multiplying not by a half, but by 2. So now I would have to let x be a half, and I'll have 2 times a half cubed to get 1. And so what I end up getting is this red curve, and you can see this point has now been moved in. So these are horizontal stretches and shrinks of one another. Okay, now the interesting thing is when we look at them visually, sometimes I could say, well, this point is being pushed down. So sometimes we can describe a horizontal stretch or shrink as a vertical one. Anytime we're squishing something this way, it's going to look like it gets pulled. And anytime we're pulling outward, it's going to look like it gets flatter. But we have to be careful that we would say by the correct factor. So for instance, here with this 2x cubed, I could rewrite this as 8x cubed. So it would be a vertical by a factor of 8, okay, instead of by the 1/2. So we want to be real cautious, and so I recommend that you just stick with calling it what it is. So let's look at the general rule. How do I know if it's horizontal instead of vertical? Well, vertical was a function times a number. For horizontal, what we actually want is we want to multiply the x value by a number and then put it into the function, okay? So what's going to happen here, if c is greater than 1, then this is going to cause a horizontal shrink by 1 over c. So in the case up here, c was 2, so it was a shrink by a half. Okay, if c is between 0 and 1, then it will be a stretch by 1 over c. So in this case here, we were using a half, so 1 over a half is 2, so it was a stretch by 2. Okay? All right, let's look at this example where I don't have a function rule, I just have a graph. The first thing I want to do is label some points so I know what I'm dealing with. So this is at -6, 0. We'll call this one at 0, 6. And this one is at 6, 0. Let's go ahead and name the endpoint over here. And then we'll put a point here too. Okay, so I have 5 points. No matter what I do to it, whether I am multiplying by 3 or the third, I'm going to keep this shape. I'm just going to either compress it or stretch it, okay? So let's take the first one. We're going to do f of 3x, okay? So that means I'm going to do a horizontal shrink by 1/3. Now, since it's horizontal, that means I'm taking the x times a third. So in each point, I'm going to multiply the x by 1/3. The y gets left alone. I'm only affecting those x values. Okay, so when x is 0, it's going to stay 0. Okay? Okay, so now I have 5 new points. So let's plot them. So I'm going to go to -3, 6. I'm going to go at -2, 0, 0, 6, 2, 0, and 3, 6. Now I just have to connect it with this same shape. So on the left-hand side, it was a U. And on the right-hand side in quadrant 1, it looks more like a V. So you can see the original curve has just been compressed horizontally. Okay, now let's say we do the f of 1/3 f of x. Now this is a vertical shrink. Now, if it's a vertical shrink, that means I'm going to take y and multiply. So now all the y values are going to change. So let's take each of these points. Okay. So now I'm changing the y. So the -9 will stay, but the 6 is going to divide by 3 and get 2. The -6 will stay, the 0 is going to get divided by 3 and stay 0. So I'm going to divide each of the y values by 3. And when I plot those points, I have to go all the way out here to -9, still at 6, not at 6, at 2. Okay, at -6, I'll be 0. At 0, I'll be at 2. At 6, I'll be at 0. And at 9, I'll be at 2. So I have this U here, and then straight lines. So now you can see it looks like everything has been compressed this way. It makes it look shorter. Okay. In the first one, it didn't get any taller, it just got skinnier. Okay. All right. Now let's just kind of go through a few and see what's going on here. So in A, I'm multiplying by 4. 4 times the square root of x. So this 4 is on the outside, so it is a vertical stretch. And you can see in the picture that the point got pulled up vertically. So it's steeper, okay? If I multiply it by a third, this is now still on the outside of the square root. So I now am bringing it down and I'm making the curve flatter, okay? In the last one, I'm now dealing with x squared. So purple is the parabola of x squared. But now I'm putting this 1/2 on the inside. So I'm taking these points and pushing it out so I get a horizontal stretch by 2. Whereas this one was a vertical by a third. So that would be a shrink. And this one is vertical by 4, so it would be a stretch. Okay? All right, let's just name these. Now I'm putting all of the information we've done in the last video and this one. But what we want to make sure we do is we remember PEMDAS. We remember what our algebra tells us about the order in which we calculate things. So whatever is being calculated first, that's the first thing that's being affected in our transformation. So I'm going to start on the innermost piece. So that is going to move me to the right 1. Okay, and then I would square it. That's just giving me my basic function shape. And then I'm going to multiply by 2. So that's a vertical stretch by 2. And then finally, we're going to do the plus 3. And that moves it up 3. So the order is going to be important. So let's keep our PEMDAS in mind, which means we have to start on the innermost parentheses with this 2. So that means I'm going to go to the left 2. Okay, now I'm going to go to this 1/2, which is still inside the parentheses, notice. So that makes it a horizontal stretch by 2. Since it's a half, I flip that over. Now I square it, and then I deal with this negative outside. And so the negative out front makes every y value go negative, and so it's going to get flipped over the x-axis. So it's a reflection. Okay, the last one, again, I start on the inside, so that's 2 to the right. Then I square it, so now I have my function shape. And then I'm going to multiply by a third, so that's a vertical shrink. And then lastly, I do this -1, which is down 1. Okay? All right, take a minute, soak that in. Remember, start from the innermost piece and work your way out so that you don't, if any of the calculations interact with one another, you don't mess up the way they interact. Okay. All right, last one here. Again, we don't have a rule, we just have a picture. So I'm going to name some points. So that's at -4, 0, 0, 2, and 4, 0. Now let's name the rule. So I'm going to do a horizontal shrink by 1/3. Then I'm going to do a vertical stretch by 2. And then I'm going to move up 1. Okay, so this is going to multiply x by 1/3, and then y by 2, and then add 1 to y. Okay, so let's go through this process. So -4, 0 is my starting point. Horizontal by 1/3 would now give me -4/3, 0. Vertical stretch by 2 is now going to give me -4/3, and then 0 times 2 is still 0. And then I'm going to go up 1, so I'll at -4/3, 1. So that would be about here. Okay. All right, then we're at 0, 2. So the horizontal by 1/3 is going to stay 0. The vertical by 2 is now going to make that a 4. And then I'm going to go up 1. And I'm now at 5. Okay, why did I put 4/3 there? I don't know. Hold on, let me fix that. Okay, so I multiply x by 1/3, then I multiplied y by 2, and then I add 1 to the y. So 0, 5. Okay, and then our last one, we're going to go at 4, 0. Well, it's going to have the same impact that -4, 0 did. So I'll end up here. And then I just connect the same way that it's in the original picture. So between these 2 points, it was this upside down U. And then on the outside, it was straight lines. Now I do want to remember I had a vertical stretch and a horizontal shrink, so they should look steeper than I began with. If you have trouble with that, you can take an extra point. This one's at 6, 1. And so I could go through this process again to figure out what it would be at. Okay. But you can see we have pushed it in, pulled it up, and then moved it up by 1. Okay. All right, so here's just an overview of all the rules. So you can pause the video and take a little bit of time to look over that and see what the different rules is for the shifts. The shifts are what we would call translations, left, right, up, down. Reflections are what flip the graph either across the x-axis or the y-axis. And then we have our stretches and our shrinks. So hopefully that helps. Now you have some tools in your toolbox so that you can just you just have to memorize the basic shapes of graphs like x squared, x cubed, absolute value of x, natural log of x. And then we can do all sorts of things with them and you can still be able to graph them on your own. So hopefully this is helpful. We will see you next time. Bye-bye.